Добрый день. Меня зовут Антон Дорфман. Сегодня мы поговорим про исследование.
Hello everyone. Today we are going to talk about a large-scale study of Mitsubishi PLCs, different series, well, rather several series, and maybe.
Сейчас на экран выведут QR-коды, пока для Telegram.
Okay, now you're going to get the QR codes for the Telegram chat. If you have any questions, please submit them via this chat. Right, there it is.
Так, ну я надеюсь, все успели отсканировать этот QR.
Well, I hope you all had enough time to scan the QR code. If you didn't get enough time, as far as I understand, from time to time you will be seeing it on the side screens.
Итак, немножечко о себе расскажу.
Okay, a couple of words about me. Let me introduce myself. I am a researcher of industrial PLCs. I've been in this business for a long time. I've got experience of reverse engineering and exploration of various devices. I authored.
Также являюсь автором процессорного модуля NIOS 2 под.
I authored several CVEs and attack scenarios and a processor module for IDH, and I'm also a speaker at different conferences. Now, in my daily routine, I reconstruct protocols, I analyze various data formats, I look for vulnerabilities, and I also do shell codes for firmware. I come across all kinds of architectures, and here in the order of priority, or rather the frequency of my encounters with them, all the CPU architectures are listed. And then if there is no processor module for particular architecture, I usually design one myself. Sometimes I find hints in executable files. It's wonderful if there are debugging symbols, and the worst case is when there are no strings at all. Now, this is going to be the content of my presentation. I'll start with a brief introduction. After that, I'll move on to the back story, the research that preceded the one that I'm going to present today. So it's already over, but you need to know about it to better understand my subsequent narrative. And after that, I'll describe several stages of the current research. Item 04 is reverse engineering. Hopefully you'll all survive it. And after that, I'll move on to vulnerabilities, and I'll explain how they can be exploited, what our options are, and there will be also a demo. Now, in a couple of words, what a PLC is, if you are not familiar with PLCs. They are the foundation of many industrial systems, control systems. They are pretty secure. They have their own hardware component. They have their own software. It comes in different flavors. Usually there's real-time operating systems for the device to be able to respond quickly to the incoming inputs and to control the mechanism it controls quickly, real-time. Well, nothing else needs to be added to that. Different file systems, different file formats can be found in the software. Sometimes there is security different defenses and different network protocols. Some of them are well known, and then there are also undocumented and proprietary protocols with which I work that I deconstruct.
Кейс у нас случился.
And, oh yeah, by the way, no, I'll talk about the case a little bit later, but for now, as it happened,
Следовать
I was lucky
различных линеек
to take a look at several Mitsubishi series PLCs. I started with FX5U. It's a small PLC, not very powerful. It's used in small automation systems.
коллеги принесли
And then the colleagues brought two more PLCs, L26 and Q06.
часть доклада, она будет посвящена немножко этому.
And the first part of my presentation will be focused on FX5U, to give you an idea of what I will be discussing later on.
RCE, это L26 и Q06. И казалось, зачем этим заниматься?
Why, you might think, reverse engineer these PLCs? Well, first of all, I'm curious. I'd say I'm very, very curious.
Потому что
And secondly, this kind of work is relevant
атаки на различные системы.
because this phenomenon does exist. Different industrial
Обзор
devices are coming under attacks.
все началось с такого
So to update you on these attacks, it all started with Stuxnet, worm.
программу Ирана.
It disrupted the Iranian nuclear program.
Для примера два
And to the left, you see two more worms in Destroyer and the Pipe Dream. And in red, you see the names of industrial protocols that they engage. So this is important knowledge. But of course, there may be worms, other worms that might be targeting proprietary protocols, and it's best if we are familiar with them before they attack. On the left, you can see some of the attacks, the best known ones from recent years.
не только
Yeah, we can see that they affect not just the industrial sector, but virtually everything that happens in our lives. So this is an extremely curious and relevant topic. So now let's turn to FX5U. This is how this PLC looks like. That's the appearance, that's the face. It has different indicators on it, inputs, outputs.
стояла такая задача его исследовать.
And the objective was to study it, to explore its protocols. Then
Некоторую
I had to design a system of scripts so that I could communicate with this PLC and, if possible, identify vulnerabilities both in the protocol and in the controller.
Первое, что я сделал, я посмотрел
First thing I did,
да,
I reviewed several traffic dumps before the PLC and the engineering utility,
некоторые скрипты.
and based on them, I drafted some scripts. Of course, before that, I scanned the protocols. Over here, you can see 3 UDP and 1 TCP. Well, they are ports, actually, UDP and TCP ports. So these scripts,
Последовательно структуру протокола
they already had kind of a structure, and they worked. When I ran the scripts, the PLC would stop. So I celebrated my first success. After that, we wanted to deep dive into this issue. Then we realized there is no firmware. Well, actually, there is firmware, but it's encrypted, and we can't decrypt it. And our hardware guy tried to get it directly from the chip. He failed, And so we have a PLC, but there is no firmware. What do we do next? Usually, if it's an IoT device, it may just sit on the shelf and accumulate dust. But this time around, I decided to proceed with my research and try to bypass the issue. First thing I did is the rule everybody knows. RTFM rule. Read the manual rule. I learned something curious out of it. There is a file system. There are devices, different areas of the memory that you can call and derive some variables out of them and record them. And I learned also that this PLC can be controlled with files. It can be configured with files. Then I decided also to look into the utility, which is called GXWorks 3. I retrieved out of the traffic between this utility and the PLC, I retrieved 3 kinds of valuable information: the commands, the codes of the commands, the devices, which devices are there, and also how can the settings be changed and how they can be obtained. In addition to that, we had another pleasant surprise. GXWorks had a simulator. They can simulate a PLC on a computer. The simulator has a similar protocol, and I decided to dig it deeper. I found a DLL in this simulator, and these are the lines FX5U, CPU. It's just a simulator. It's just that this simulator implemented nicely the PLC logic. I decided. Oh, and by the way, I also brute forced various command devices, and I learned that the simulator supported many different commands. There were 53 commands on the PLC in that version, and I found 54 of them. Then I proceeded with reverse engineering. I got lucky again. The simulator didn't have any text strings. But all my earlier findings, the brute force and the manuals, helped a lot. So I explored this simulator with a debugger. And these are the results on FX5U. I got the protocol description, I got description of devices and commands. I have my script system now to interact with the PLC, and I even found, together with my colleagues, 15 different vulnerabilities on the PLC and in the software that communicates with it. If you are interested to learn more about the details of this study, then you can find them out from these talks. The Skyload is the first one, the red one. The white one is the presentation I made at Off-Zone. And the blue one is NOCOM. It's in English. And the second part of the study is described there in English. And now let's turn to L26 and the other one. When a protocol researcher comes across a PLC, the first thing we'll look at is traffic. Many of you first take a look at the traffic. First things first. And you know, human brain is unique in this respect. We always look for patterns, and you can use your eyes to look for patterns. You will always find a pattern everywhere you look, even by taking a quick glance at this slide. Probably you will notice a pattern in these numbers. Well, I looked at it, I saw a pattern, and we call it an reverse engineering as a joke. So this is me reversing the protocol. Over here you can see some fixed values
где размер.
And you can also understand the size of the packet and several other fields. We are not going to perform our reverse engineering. I did a lot of work, and I got a description of this protocol for FX5U. So when I had to reverse engineer the protocol for the new device, I compared it against the old device. So at the top you see the FX5U, and the L26 protocol is at the bottom. So you can see here that we have here the strings with the names of the controller, and it turned out that the protocols, they are not identical, but they are pretty close. They have similar fields. It's just that these fields,
И значение некоторых
they are slightly in different positions, and the values are slightly different. So I decided to take the second of the new PLCs and compare that one as well. And I saw that the Q06 is close to L26, which is close to the oldest one. After that, I decided, okay, this is a promising start.
И решил разобраться с портами и протоколами.
And I decided to learn more about the ports and the protocols. At the top left corner, you will see the ports open for FX5U. We discussed them already a little bit. To the right, you see the ports open for L26 and Q06.
Заметить, что есть
You may notice that, again, the ports are different, but there are patterns, templates, if you will. And in the middle, you'll see documented protocols for the Mitsubishi PLCs. Unfortunately, none of them matches the protocols that I was investigating.
полезная информация.
Yes, the documented protocols had some valuable information, but I couldn't use it very much. Well, I found the actual undocumented protocol. It's called MelSoft.
Определение портов.
And I found the ports definitions for different series.
TCP, UDP. Летает один.
TCP, UDP, the same MelSoft protocol is used. Inside is all the same. It's just the ports are different.
Попадает.
And I decided that, okay, if there is such a match and the protocols are so close, they're so similar, maybe something else will work, a different trick. And I decided to first apply the script system. This is how it looked like for FX5U. I changed the fields slightly in the scripts, not in all of them actually, not at all of the topmost scripts, but
Protocol abstraction layer.
in the protocol abstraction layer. When I changed some fields there,
Система скриптов заработала.
I made sure that this script system started working on the new PLCs,
Все хорошо.
both of them. I decided that, okay, if I'm proceeding at such a good pace, maybe I can be revenged and I would be able to get the firmware finally. Well, what could help me is the vulnerabilities that I have already detected before. Why not try them out on the new PLCs? Here you can see the list of vulnerabilities, well, some of them, the ones that I found in the earliest study.
Они все касаются инженерной утилиты.
They all pertain to a utility that's called GXWorks 3, and
Security feature.
they are more about various security features of the PLC, passwords and this and that.
Ну, основная мысль, что они не подходят. Почему?
The main idea is that they will not. My idea was that they would not fit because the old PLC interacted with GXWorks 3, while the newer ones worked with version 2. Over here you can see the FX5U PLC vulnerabilities. The 6 topmost listed here are for network communication. They wouldn't have helped me in any way in what I needed with the new controllers. Although all series turned out to have these vulnerabilities, but the two bottommost vulnerabilities could have been of use to me. I decided to start with the bigger vulnerability, the one with the highest score. This is an integer overflow when calling a device. This is when a device is trying to read, it creates a variable address, and if we set this address of a variable in a certain way, it's shown here in red. Then, if you substitute it into Formula 1, you will get the real variable address, the real address in the memory, and the device will be equal to 0. So there is a test. If this address is 0, it is equal to 0, then the test of the def offset that we entered as a very high value will not happen, and then you will go outside of the memory of this device. So this is quite a straightforward vulnerability, but it can lead to some considerable damage. I'm going to show you a quick demo. This is how it may look like, and this demo actually is from standoff, from one of these stands at standoff. I asked my colleagues to video this demo. This is a pumping station. It has different pumps and valves. There is a PLC that controls all of that, and there is a SCADA screen. You can see here. Oh, this is a denial of service. Now, this is the SCADA. This is the Mitsubishi FX5U. Is blinking at us, winking. Now we start the process. Everything stops. SCADA is horrified, and this is the PLC in a mode that you can take it out of only by switching it off completely and restarting it again. It's completely dead for the automation system. So it's a simple error that led to a denial of service. I decided to try something similar with L26. So I got my revenge. L26 threw out a huge dump. Here, in the upper part of the screen, that looks like code. You get a lot of zeros, and then there is an offset, some bytes. It looks like code. In the lower box, you will see the name of the PLC, the actual name that we met in the traffic, which is yet another good sign. So we've got a dump. And yes, there were many other interesting strings there that were telling me that this is actual firmware, but I can't show all of them to you today. Well, otherwise the presentation would never end. So I decided to use reverse engineering to investigate it further. To apply reverse engineering, you have to upload the firmware into disassembly. But in order to do this, we need to know which processor is installed there. And again, I got lucky. It's the window at the top. You will see there the copyright from the NEC Electronics Corporation. And even the name, RX73000. This is a 32-bit real-time operating system. I asked Wikipedia about NEC. Wikipedia told me that they had a V810 processor. And I found something looking similar in the dump. V850E. So this turned out to be the processor on which this firmware was running.
Я загрузил ее в disassembler.
I uploaded into the disassembler. When you first load the dump into the disassembler, it usually tells you,
И я вам disassembler.
press a key and then I will disassemble.
После этого делаешь автоанализы.
And even if after that you run an auto-analysis, it will not always that is going to deliver you the results. Well, I press the keys. I saw that, well, the size of the dump was too big and it didn't correspond to the result that I was getting from the disassembler. Well, I could be hitting the C key for a long time, but this is not optimal. That's why I decided to perform some pre-processing. That's a set of scripts. They are my own scripts. And I got a lot of function. Well, and by the way, at the top you see the yellow status line, and the blue line shows you the code. And after pre-processing, you see there is more blue. That means that now there is more code, and this code is located in particular locations.
Не 245, 20 000.
Not 245 functions were returned to me, instead 21,456 functions. If you're interested about the technical details of pre-processing, then here is a link that will take you to a page days,
Дальше
to a presentation that was delivered at Page Days 2 years ago.
их исследовать, надо их загрузить по...
Now, to continue with my investigation, I also needed to understand which addresses now I must use. Which modules do we have there? Now, I took a look at different pieces of code. I saw that there are patterns there. Certain registers have certain offsets, and then there is jump to this offset. So I realized that there are at least 3 modules,
То есть 3 блока кода,
3 blocks of code.
адреса, по которым...
And in white you see here the addresses, the alleged addresses for where they are located. I also found this structure of the firmware. You can see it on the left. There is the main part there and the network part. The main part of the firmware is responsible for the logic of the PLC, and the network part is responsible for the network interactions, not the protocol, not the proprietary protocol, but the low-level network operations.
Карта в память.
This is the map of how this main part is uploaded into memory. I will stop here with my reverse engineering story. After that, all the routine actions followed, and you may get sleepy if I continue talking about that. Now let's turn to the results and the bugs that I found.
Опять же, исследование фикс.
During the research of the FX 5U, I dove into the devices and commands. Highlighted in blue are the devices, that's table 1, and on the right-hand side, highlighted in white, are the manual codes for the devices and the relative commands. I decided to double-check that, and it turns out that for the L26Q06, they coincide. The devices codes are different, but they coincide with the ones in the manual, which was good. When I analyzed L26Q06, I detected 5 remote code execution vulnerabilities. They are listed here. And from the get-go, I'd like to mention that there are 2 bugs in this slide, I mean, in terms of the format that I managed to detect just recently. At the bottom of table 1, it's not the use of password, it's also remote code of execution. And the products susceptible to these vulnerabilities don't have its own CVEs. So these are the bugs that I detected. As you can see, these 5 vulnerabilities can affect quite a lot PLCs of the L26 series. And the advisory vendor on the 15th of March 2024 released the info on the bugs, which means that they are quite recent. They are all different, but their structure and principles are similar, and this is what I'd like to go over. If you use a variable, there is a control from the well, you check the initial and the end addresses of the variable, and as well as the initial offset and the memory address of the device itself. And the problem is that by using certain manipulations, we can evade these checks. Highlighted in white are the memory regions that we can send the message to. The vendor is still working on eliminating these bugs and vulnerabilities, but well, I'm not saying that they can be exploited all the time. There are some details that I'd like to brief you on.
Бага есть.
So the bug has been detected, and I came up with several ways of dealing with these bugs. The most awesome case is as follows. I took revenge on the bug because I got total access and the firmware access was gained, and based on that I identified other bugs and detected their limitations. As you can see, it gives you all the possible options of PLC names that have very similar firmware. So that's the memory read command. Case 2 was as follows. I was unable to get total memory access, but rather gained partial access. And actually I gained access to several small parts of the memory. It turned out that in the GX works, there are settings for devices, and you can specify their range. And by manipulating the range of the settings for a device, I managed to read larger parts of the memory of the X double. Case 3. Well, I decided to have fun here, and I decided to create the simplest dumper. Shown on top is the traffic returned by the PLC name. That's 0101 model name command. On the left-hand side, you can, in the middle of the slide, you see part of the code. And the zoomed-in version, the relevant zoomed-in version is shown at the bottom. But what if the offset, by the way, is circled in the slide? What if we replace this offset with our own offset? Just for the sake of experiment and demonstration, I decided to use the series name, that's MELSEC L series, and I just rewrote it. Following that, it's going to look like this, and the code is offset by a line. And if you send the same command 0101 model name, you're not going to get the line with the name, but rather the line with the series. So you can download the entire firmware in pieces of 16 bytes. In certain cases, this is the only way to download the entire firmware.
В одном из кусков был этот код.
And I managed to download the other parts of the firmware. Let's move on to the remote code execution. It's a simple example. How do we know that we can control the code within PLC? The easiest way is to send a command with your known response, so that you understand whether you're going to get a response to another command. That's the simplest way. 0C02 is the command that was sent, and it returned an error. This is highlighted in blue. This code part is at the bottom on the left-hand side.
Вот. И я просто прыгнуть на команду. И вы видите,
And as you can see, there are zeros against the NOP command, and highlighted in yellow on the on the left-hand side. Just remember this part of the code because it will be useful later. So using the 0C02 command, when we send it, it returned from the PLC a response to a different command, which means that you can control the code within the PLC. Let me run a demo. This is the command line. Well, unfortunately, I cannot run a full-scale demo, so anyway. The first thing we're going to try to do is get the PLC name. This is the model name. The error code is zeros, that's success, and highlighted in red is the model series. Then we use the 0C02 command. It's not registered. We don't know what it does. It returns the error code. As you can see, error here. And there is data that allows us to understand what this error is all about. Now let's patch the code, execute the vulnerability. So we patch the 16 bytes from this file, and these are the zeros that we saw before, and I told you to remember them. This is what we're going to patch, and we get an undocumented error. The code are all zeros, and this is the name of the CPU. Well, I'll take questions later if you don't mind. Let's go back to the previous screen. I told you to remember this part of the code. And that will help me to patch it again. Let's try to use the 0C02 command, and as you can see, it returns an error again.
Все работает. Ну, в результате исследования.
Well, ultimately, as a result of this research, we drew certain conclusions. Well, they might seem simplistic and trivial to you, but vulnerabilities can migrate from series to series, though the code bases do differ and the CPUs are different, but the vulnerabilities can still migrate between the series. Another simple conclusion, obvious conclusion, is as follows. If we research one series, it will speed up the researchers of follow-up series. In certain cases, denial of service vulnerabilities might evolve into RTE vulnerabilities for other series. I already touched upon some of the PLC tech details, the difference between various series and protocols. The way engineering utilities can help you in the post-op, I briefed you on certain details, as well as the way to create a simple dumper by using a very simple command. Thank you so much for your attention.
Я так понимаю, здесь
Well, as far as I understand, I did receive some questions in the chat box.
так. Здесь от предыдущего доклада.
Well, I guess these are the questions for the previous speaker. Let me update the page, refresh the page. Yep, there it is.
Вопрос. Есть ли средства защиты для ПЛК или единственное...
Other protection means for the PLC, or is the only way to protect it and is to collaborate with the vendor or such smart researchers as you are? Well, there are security systems for automation systems rather than PLCs. In other words, automation sensors are built in, and they can identify malware traffic and respond to it. And of course, smart settings in the PLC.
Ну, точнее, тут настройка...
Well, actually, the settings are not done by the vendor, but rather by the operator, and you should use all the protection means in the PLC. And as a rule, vendors respond quite quickly. And by the way, I'd like to appreciate what Mitsubishi does, because they quickly respond to questions, they ask their own questions, and any problem can be solved within a week, and they also release patches on a regular basis. In other words, as far as collaboration with the researchers is concerned, I don't know whether collaboration with myself will help you protect your PLCs. We send all the details to the vendor so that the vendor releases patches to ensure security. The next question is as follows. How did you become a reverse engineer? Well, that depends on what programming language. What programming languages did you study, and what apps do you use? Well, it's outside of the scope of this presentation. So, did you use anti-setting tools in the PLC simulator? Well, we didn't. We use a DLL tool.
Не то, что антиотладочник. Дело в том, что там
The matter is that
она не грузилась в обычном виде.
it could not be downloaded as usual. Code lines, code parts were uploaded into a virtual memory, and it was difficult to use the debugging tool. The next question is as follows. What's the most unusual bug exploit that you detected for Mitsubishi, and what memory architecture aspects turned out to be key for the reverse engineering? As for the most unusual exploit, well, I would say that it was the dumper, because it allowed me to download the entire firmware. And there will be a presentation, a separate presentation on a different research. And there was a code line that I got access to, and by gaining access to this line, I also used a dumper to download the firmware. As for the architecture aspects, well, Mitsubishi focuses on PLCs and the way they use in-memory projection from a variable to a specific memory cell. I would say that this is the main feature, as well as the setup of the teams and the protocols.
Так, ведется ли легирование, наверное, логирование на PLC?
Can you log into the PLC and can you restore the chain of an attacker in a PLC after the attack? Some PLCs do provide system logging so that we understand what was the root cause of a crash, but it will not help you retrack the chain of the footprints left by the attacker. The next question is, can you give us more details on the root cause of the inability to establish the entire chain for the PLC? Initially firmware was encrypted and all the follow-up versions were not. The sub-question is, if you adapt the vulnerabilities and exposures, can you use them to improve your firmware? As far as Mitsubishi is concerned, I did adapt them even for other series of PLCs that I did not mention in the presentation, and it works. The protocols are very similar, and this research was split into two parts. I was lucky, and by using the backlog, I managed to download the entire firmware. The next question is,
на все найденные уязвимости были написаны правила.
All the vulnerabilities detected were described by the soft and SIM roles. We do have eSIM. This is a product that we offer, and as well, I know that the rules were written for this product.
Дам по прошивке с PLC.
What are the specifics of the PLC dumper development? Well, we start with the simplest thing. If the firmware or an update to a firmware is available online, you can download it. If it's encrypted, then you have to decrypt the updates. And the most complicated way is to get the hardware. FX5 was the case when I didn't even have the hardware. What's Mitsubishi's attitude to your hacking their PLC? Their attitude was quite friendly. Actually, they thanked me for it. How can you download a patched firmware? Since it's the device access vulnerability, this is the bypass that I mentioned.
Он отправляется по конкретному смещению, которое я здесь, конечно же, не показываю, потому что это... Да, просто 16 байт шлется в нужный.
You just send 16 bytes to the right device with the right offset and the right margin, and it is stored in memory. We are out of questions in the chat box. Are there any questions from the floor? If there are, please use a mic. We do see some hands raised, so please bring a mic.
Спасибо за доклад. У меня такой вопрос.
Thank you for the presentation. When you inject the code, was there more additional space? Could you populate it with your own code, or was it limited? I mean, was the address space limited? If you want to send a Trojan worm, can you do that? In this particular case, I used code lines, but I'm an experienced guy, so you don't need to use separate code lines. You can use text lines as well. And the structure was quite rigid, and in that case I could not populate the space with my code. But They were duplicated code lines, identical code lines, and I could have done anything. And my teammates and I even played around with the controller. Thank you for the presentation. Well, it's quite clear that the operating system is not that relevant, but I'm just curious. Am I right in saying that every PLC manufacturer offers some firmware which was written from the scratch, or did you see any open source real-time systems used as a basis? So PLC manufacturers will just develop their own app and upload it into the open source operating system. Have you ever tried to reverse devices on RX RTOS? It's a national operating system developed by as part of an import substitution program. Some vendors use well-known operating systems, real-time operating systems. As for the open source real-time operating systems, I saw them in certain firmwares, but not in the PLCs, but rather industrial devices. So I did come across such cases. As far as Mitsubishi is concerned, and Japanese vendors in general, I would say that they usually have something unique and developed in-house. Sometimes they even use their own CPUs. They might have an outsourced manufacturer, but usually you cannot really identify it from at one glance. As for the first part of the question, the answer is no. I've never used that RT operating system. Thank you so much for your presentation. It was interesting. It was cool. I dealt with it a bit. I have two questions, if I may. The easiest controller, the less secure controller, what is it? And what's the most secure controller for a researcher? And who are the manufacturers? So the worst or the least secure and the best or the most secure controllers, what are they? Well, I can share my own experience with you. And the least secure device. Well, it was not a PLC per se, but it was an industrial automation device by Schneider Electric, and there was a bunch of built-in.
Но их можно было найти только реверсом. То есть просто так, то есть они были вшиты в биналь.
That were integrated into the digital controllers, and we used this vulnerability to change the settings in the PLC, and so similar to switches. A bit. They're similar, but you had to zoom into it to better understand. I call it disguised web app because it can be used in multiple scenarios. As for the most secure PLCs, I would say Mitsubishi PLCs, but you were successful in hacking them. As for those that I failed to compromise, actually, sooner or later you can hack anything. It's only a matter of time and effort and patience, as far as I know. The most secure PLCs are the ones that are researched most frequently. If you take a look at the CVEs and their appearance time, you'll see that it's Siemens controllers that have been researched most of all. And I was told that their firmware is extremely complicated. Thank you.
Добрый день, спасибо за доклад.
Good afternoon. Thank you so much for your presentation. Maybe I misunderstood what you said, but their communications protocol is very similar to Medbus.
Вам не кажется, что проприетарных...
Don't you think that proprietary communications protocols does more harm most of the time? And maybe in high-risk systems, it makes more sense to use open systems. Well, it's a big question mark, but how do you tell them about that? Because, you know, they only learn from their own experience. That's the first thing I want to mention. And secondly, as of 2017, they sold over 16 million PLCs. So what do they do with their code backlog? They are stuck with the architecture that already works. Well, switching over to something else, even if it's more secure and more popular, will cost them a lot of money as well as effort. So I believe very few vendors would actually agree to that. There's another hand raised right on the other side of the hall.
Добрый день. Спасибо большое за доклад.
Good afternoon. Thank you so much for your presentation. I was just wondering, have you ever considered a probability of using the black box fuzzing at early stages of protocol reverse engineering and detecting CVEs? I think it would free up your time because the machine would do most of the routine and change values in the protocol fields. Well, we use the phasing machine. What engines and heuristics do you use for fuzzing if you provide feedback?
О том, что с ПЛК я мог как-то пинговать его после каждого.
I could ping PLC after every request, but we used handwritten scripts based on the commands I demonstrated to you. So I did not use anything open source back then. Thank you so much. Got it.